So we've got a Unit 4 or Paper 4 question, or depending on what exam board you sit in, might be a bit different, but it's a projectiles question, mechanics. So this question, so it says a golfer hits a ball from a point A with an initial velocity of 35 meters per second. So I'm going to build my own diagrams just so I can draw on it and everything. So the lake ends right here after the 100 meters. So it says it goes from point A with an initial velocity of 35 meters per second. So it's going up 35 meters per second with an angle of alpha above the horizontal. And it says sin A is 0.8. The ball passes over a tree which is growing in front of the lake. The lake is okay. So the rest of it is shown in the diagram. So it says determine whether or not the golf ball will fall into the lake. So we know that the lake, we know where the lake is horizontally and vertically, because the vertical would just be 0. And we know it's 117.5 meters from the origin horizontally. So what I think we should do, because horizontally there's only 3 things, there's the distance, the speed, and the time. So we know the speed because we've got the initial speed here, and then we also know what the horizontal is. So what we could do is find out the time it's going to take to get to the lake, and find out how far away from the origin it is horizontally, because the time will be the same vertically and horizontally. So what we're going to do first is we're going to get this in terms of the vertical and horizontal. So horizontally, so you can pretend that we've got like a triangle here. So we'll say this is ux, x is for horizontal, and this is uy. So uy, so let's say that we make a triangle. You can either do it as a triangle, or if you might do physics, it's a bit easier to understand. So this is how the diagram's showing it. So this is u, which is 35, and then we've got the angle here, so you can do trigonometry, so opposite, so this is opposite, which would be the same as this, adjacent, which is the horizontal, and this would be the hypotenuse. So the opposite would be, so we've got O and H, so that we know that's sin, so 35 sin alpha, and then the adjacent would be 35 cos alpha. It should always be the same. If it's from the horizontal, if the angle's from the horizontal and it's going up, then it should always be the same. Like it should be cos for the horizontal and sin for the vertical. So now we know uy is 35 sin alpha and ux is 35 cos alpha. And we know sin is 0.8. Sin alpha equals 0.8, which is the same as 4/5. So we've got a 3-4-5 triangle. So cos alpha would be 3/5. If you don't understand that, just leave a comment and I'll reply to you. So the next thing we're going to do is we're going to see if it lands or not. So we're going to figure out the time it takes from the origin for it to reach 0 again. So vertically, and we're gonna say that up is our positive direction. So whenever it's moving up, it's going to be positive. So we do SUVAT. So the S, so we want it where it hit the lake, and the lake is at 0. So the S is going to be 0 meters. And we also know it's going to hit 0 here. It hits 0 here and here, so we should have 2 values for t, so we might be looking for a quadratic. U, we're looking at vertical, which is uy, which is 35 sin alpha, which is, we know sin alpha is 4/5, so 35 times 4/5. And then 5 goes into 35 7 times. 7 times 4 is 28 meters per second. The terminal velocity we don't know. Acceleration we do know, which is the speed of gravity, or acceleration of gravity, which is 9.8 meters per second squared. But being as we've said that the up is the positive direction, the acceleration is going to be negative, because acceleration, gravity will be down, yeah? Gravity is always down. So down would be negative and up is positive. And then the time is what we want to find out, so let's say that's t. So we've got s, we've got u, and we've got a. So I think the best thing we should do is this equation, s equals ut plus half at squared. So u is 28, so we've got 28t, s is 0, plus half times minus 9.8 times t squared. So being as this is negative, we should probably move that to the other side and move this to the other side, or you could say it times in the whole equation by minus 1. So half times minus 9.8 is 4.9. And this is going to be negative if this is positive, because we've times by minus 1 or moved them over to the other side. Sorry, forgotten the t squared. Minus 28t equals 0. And then we're going to see on the calculator, will 4.9 go to 28? I don't think it will. So it's giving me 40 over 7 as a fraction, but as a decimal it's a continuous number, so we're going to keep it as a fraction. So we're dividing the whole thing by 4.9. So now 4.9 divided by 4.9 is just 1, so t squared minus 40 over 7t equals 0. And then factorise t out, we've got t minus 40 over 7 equals 0. So either, let's write that a bit nicer. So either t equals 0 or t minus 40 over 7 equals 0. So t equals 40 over 7, which is 5.7142, and that's going to go on. So I'll just leave it as a fraction. So you probably get about half the marks up to this point, and then put a cross through this one so they don't think that's your answer. The reason this t is 0 is because it does that at s equals 0 here, and then it hits once again over here. So now we know the time is going to hit the floor. We can now see how far away it's going to land. So we can do that by substituting this value of t back into the horizontal. So horizontal, and we're going to say to the right is a positive because that's the way the ball's travelling, so it's just a bit easier. So we've got SUT because the acceleration is 0 and v would just be the same as u if the acceleration is 0. So horizontally, so t equals 40 over 7. U, so ux we're looking for, ux is 35 cos alpha. 35 cos alpha, and we worked out that cos alpha is 3 over 5. So then s we don't know, so that's what we're going to find. So s equals ut. You probably know that, or if you don't, and you're wondering where I got it from, just think about so velocity, or here it would be speed because we're horizontal. So speed equals distance over time. So if you want a distance, you times the time over. So then we've got s equals ut, which is 21 times 40 over 7. 21 divided by 7 would be 3. So we've got 3 times 40, which is 120 meters. And then to finish off, you would just need a little sentence to say it will not fall in the lake because the distance is more than 117.5 meters, which is where the lake ends. Or maybe if it was less than 17.5 meters, you would say it's not because it's less than that. So we'll say, so therefore, the what is it? Is it a ball or? Yeah, the ball, the golf ball. The ball will not land in the lake as 120 is more than 117.5. And then you should get your last mark for that. So that was 6 marks. And then we've also got B. Find the magnitude and direction of the velocity of the ball as it passes over the tree. So, if we have a little think about it, when it passes the tree, it's going to be at 17.5 meters. So we want to calculate what's the magnitude and the direction of the velocity. When they ask for direction, they want, so this is going this way, and then if we look at the horizontal, and then we've got the vertical as well, we want this, so we need to find the vertical velocity at this point and the horizontal velocity here at this point. The horizontal velocity will always be the same because there's no acceleration, and then the angle here would be the direction from the horizontal, and then you'd say it's this much degrees or radians from the horizontal. So let's do it to the right by here. So B. So we need to find the velocity up here. Let's think of, so we've got the horizontal velocity. We want to find this, which I'm going to mark as the vector V, because it's got a direction. It's not just going up or to the right. It's got both. It's going a bit up and a bit to the right. So we need to find the vertical velocity. So if we just have a look at a few of our equations here for the vertical velocity. So we've got v squared equals u squared plus 2as. We've got v equals u plus at, and that's it. So what we're going to do is, so for this one we need to find the vertical distance at this point from the floor. So we're gonna have to do quite a bit of work to get that, and you'd need the time for that, because s equals ut plus at squared, or you'd use this equation. So it's not really going to work. So what we should do is use this one and figure out this time, and then just put it into this, because we'd have to find out the time anyway to find the displacement. So what we're going to do to find the time is, so vertically, to find the time vertically, we need to use this or this, but we don't know v and we don't know s. So if we try horizontally with to the right is our positive direction. So we've got s, u, and t. So s, when it gets to this, it's going to be at this point. So, and the tree is 17.5 meters from the origin, or from A, horizontally. So this would be 17.5 meters. And u will be the same throughout the whole thing if it's horizontally, which is 35 cos alpha, which we saw was 21 meters squared. So this is 21 meters squared, and the time we don't know, we want to find it out, so we leave it as t. So we can find this, so s equals ut, t equals s over u equals 17.5 over 21, and we put that into our calculator, which is 0.83333, or 5 over 6. So we're going to leave it as a fraction. And now we can input this into this equation to find the velocity vertically at this point, because this is the time it goes past the tree. So if we find the velocity at this time, it's going to be at this point, which is what we want. So now if we do vertically with up as our direction. Oh, sorry guys, I wrote that with an F over there. I'm used to doing it in Welsh, so bear with me. Vertically, so S U V A T, SUVAT. Sorry, that looks a bit like a 9. So the S we don't know. U is 28 meters per second. V is all we want to find out, so we leave that as V. Acceleration will be minus 9.8, because up is that positive direction. And then T is 5 over 6 seconds. So now we can go ahead and use V equals U plus AT equals 28 plus minus 9.8 times 5 over 6. Then we can just slot that all into the calculator, which gives us 119 over 6, which is 19.8333. So we'll just leave it as that for now. And then we're going to make a little diagram. So let's take this bit by here, and we're going to just get this bit and just make our own little diagram down here. So this is the top of the tree here as it passes, and it's going like that. So the question is asking us to find the magnitude and the direction. So the magnitude would be this, and then the direction is this. So this is Vy, and this is Vx. So Vx is 21 meters per second, and Vy is 119 over 6 meters per second. So then this is basically just a triangle. Well, it is a triangle if you just move that over here. So what we can do, so if we just pretend this is a triangle, so this would be 119 over 6, this is 21, we want to find this here. So we can use Pythagoras. And then put that into the calculator. And that's giving us a weird number, 28.885, so 28.89, let's say, meters per second. So that is the magnitude, and then we need to find the direction. So if we just do trigonometry, opposite, adjacent, and we're going to use these values that we just found out, in case we might have done a mistake with the Pythagoras. So what we're going to do is, so tan theta equals opposite over adjacent, which is 119 over 6 divided by 21. So theta equals tan minus 1, 119 over 6 over 21. And we'll get 43.36 degrees. So V equals that at 43.36 degrees from horizontal. And there we go, that's that question. So I hope you found this helpful, and if you've got any questions, leave them below.